weekend. I haven't checked if you guys are in the test yet. So today I just want to wrap up Unit 1 and get a start on Unit 3. So we kind of skip a unit because we started with 2. So we went 2 to 1, now we're going back to 3. And then we'll do the rest in order. So no more confusion or anything like that for the remainder. Just want to talk about a few things in the course. I've opened up Unit 3, and if you would like to print off the learning guide and the lessons for that, that would be great. So the learning guide for Unit 3 is pretty straightforward. It's not a terrible amount of stuff, but I would like to get Unit 3 done-ish as we approach next Thursday, which is our midterm exam. So there you go. Does anybody else have any issues with the live feed? Mr. Ross, you good? All right. Oh, Christina as well. I don't know. Yeah, it might just be your connection. I'm not sure what's going on. Probably likely good for, yeah. Sorry, Ian. I've got nothing for you. No answers. Mr. Ross, you mind bringing up my computer in the background? And I will go over a couple things. Is it connected? No, I don't have VGA going right now. It's running, but it's not connected. So what we're going to do today is we are going to, I said I'd talk about rationalizing denominators. That was a question of the learning guide, so I want to cover that. And I also wanted to move into Unit 3. So it seems like we're kind of going a little bit fast, and we are. Thanks, Mr. Ross. So we will, right now, if you have a second, you can print off the lessons for Unit 3 because we'll go through those in a few minutes. Before I get to that, I wanted to see if anybody had any questions about the learning guide from Unit 1. I kind of left you guys with a bunch of stuff last day. We talked about a ton of information, and I didn't want you to have to write the test right away. So if you had any questions from Unit number 1 learning guide, I'd be happy to go through them. If not, I'm going to talk about rationalizing the denominators, which was questions 2 and 3 on page 10, so really close to the end. I think there was another question I said I was going to go over today as well, but I don't remember what it was, so maybe somebody could remind me. Thanks, Lead. I'll get to that for sure. I have some messages here. I'm going to check. All right, some people. Seems like a few people are having some issues with connections today. There was a big, not that this has anything to do with what we are doing here, but there was a big cyber attack last week. I was reading about a big DDoS attack. I don't know what that means, but crazy stuff. Shut down a bunch of the internet. Maybe that's happening again. That's why we're all so slow. It's a big cyber attack. You did. Yeah, so basically there was this, I didn't read a ton about it, but there were all of these like security cameras that people, yeah, Twitter and Reddit were down, all these security cameras that people were using in their houses, and basically the company that made them, when they put the software in them, they didn't protect them, so they were connected to the internet, and anyone could access them. So what these hackers did was they figured out that there was literally these hundreds of thousands of security cameras and other sort of connected devices that were unprotected, and they basically turned them all against the internet, and a bunch of the internet crashed. So I don't know. Some of you are having issues this morning. Maybe that's what's going on again. Page 10, 3H. That's this rationalizing denominator stuff, leads that I will go through right now. So I didn't talk about this because I'd done so much stuff last day with you guys, and I wanted to make sure that we were absorbing this slowly because it is a lot, this radical stuff. So we talked about the difference between rational and irrational numbers, and we were discussing that a rational number is something that ends or has a repeating decimal, and an irrational number is something that just continues on forever. We can only estimate them, they never end. So something like pi would be irrational, whereas the number 2 would be rational. So when something asks you to rationalize the denominator, what that means is they want you to write it in a way that the bottom is rational. So that means that the bottom doesn't have a non-terminating decimal, or like the square root of 2 is the first example we have here. That goes on forever. So we can't have that in the bottom. And this is really common in math. We'll never have these types of things in the denominator. So if something asks you to rationalize, and we'll actually encounter it again in the polynomials unit, when we're asked to rationalize the denominator, it just means get rid of any non-terminating decimals in the bottom. Or if you get rid of all the square roots in the bottom, generally speaking, the denominator will be rationalized. Ian's just updating us on DDoS attacks. Basically, when they send a bunch of packets towards something useless and they just kind of clog it up. It happens to websites too, where you know, if you have to like sign up for a website, they'll put in a bunch of requests to sign up, like a bunch of kind of zombie computers all over the place will all request something from a website at once, and it just overloads the server, and then the website can't. There you go. So the websites will crash. So that's what a DDoS attack is. I forget what the first D is, but the last DOS is denial of service. I don't know. Somebody can look it up. All right, let's rationalize some denominators here. Root 5 over root 2. We need to get rid of the root 2 in the bottom. Now, we can't just get rid of root 2. It's there. We're dividing by root 2. But we can get rid of the radical sign, and there's a trick. Well, I'll show you what that looks like. Now, let's imagine I had something like root 5 over root 2, and I multiplied it by 1. Are we all happy with multiplying by 1? I mean, I can multiply anything by 1, and it just gives me whatever I started with. That's what the beauty of 1 is. So I can just do that. I can multiply things by 1 and it doesn't change anything. So why not multiply this by 1? But I'm not just going to multiply it by 1 because that doesn't change anything. We just discussed that. But what I can do is go like this. What if I multiplied this whole thing by something like this? 2 divided by 2. That's the same thing as 1. 2 divided by 2 is 1. That's not going to change it. I can multiply by 2 over 2. It's just multiplying by 1. But Ian with the update again. Distributed denial of service. There you go. Thanks, Ian. So I can multiply top and bottom by 2 and 2. 2 divided by 2 is 1. I'm not changing anything. This is where, you know, knowing how to deal with radicals comes in a bit of handy. If we multiplied everything by root 2 over root 2, that's still 1. Root 2 divided by root 2 is 1. So I'm multiplying by 1. I'm not changing anything. I'm just kind of modifying what the numbers look like. It's just not the simplest fraction. And this is kind of the trick for rationalizing denominators. You're always going to multiply by whatever radical's on the bottom, both top and bottom. And I'll show you how that works. So if I'm multiplying the top by 5 by root 2, I'm going to get 5 times 2 under that radical. And then the bottom, I'm going to get 2 times 2. I'll show a bunch of steps on this first one, but you can just take my word for it. On the bottom, let's go top. 5 times 2 is going to give me root 10. The bottom, 2 times 2 is going to give me 4. And the square root of 4 is just 2. And that's how it'll work out every single time. If you multiply the top and bottom by whatever radical's on the bottom, then because you're multiplying it by itself, like root 2 times root 2 is just going to give you 2. I could do that with anything. If I go root 72 times root 72, I don't even know what 72 times 72 is, but I'm going to end up with 72. just because that's the definition of a square root. It's a number multiplied by itself. It doesn't matter if I multiply both these numbers under one radical sign. I'm just going to say, okay, if I can go 72 times 72, I'm going to get 72. All right, so that was the first one. That's the first one you've probably ever seen unless you checked out some of the ones in the course. I know Leeds asked about H, which was definitely a tricky one. Let's maybe just wade into this a little bit slower. Let's look at maybe B over here. So I've said that the trick is this. The trick of this is multiplying the top and the bottom by root 6 over root 6, because that's going to get rid of the radical in the denominator. All right, so on the top I have 15 times 6, and on the bottom I have 6 times 6. I'm just going to keep kind of working across here. 15 times 6, I don't know what that is off the top of my head, but I can check. 15 times 6, 90. So the square root of 90 on the top and the square root of 36 on the bottom. And then I know the square root of 36 is just 6. And that's the way it's always going to work. When I multiply root 6 by root 6, I'm always going to end up with 6. So if you want to just skip from that first step right to that last step, that's fine. I don't mind that. All right, on the top, I have this root 90. Now, I've rationalized the denominator, but I haven't simplified my numerator here. I have 90, and I know there's a perfect square that goes in there. I know at least a 9 times 10 will go in there, and if I broke it up, I'd get 3 root 10 over 6. Now there's one last step I can do here because I have a 3 and a 6. I can simplify that. I can divide the top by 3, and I can divide the bottom by 3. And I'm going to end up with 1 times root 10, or just root 10. And on the bottom I get over 2. So you can see how something as simple as trying to get rid of the root 6 in the bottom here can turn into several steps to rationalize it. And then once you've rationalized it, you got to simplify it so you can run into some long questions here. Now, I've shown a lot of steps that you might skip, but I'm just trying to make it as clear as I can. So as long as I can kind of follow your steps. For instance, if you were to go from root 90 right to 3 root 10, I would be okay with that. I can follow that. So if it makes more sense for you to break it down into root 9 or root 10 and then do the next step, you want to do it in 2, that's fine. Whatever works best for you. All right, let's do one more and then we'll get to H. Just looking at H is making me a bit nervous. Let's do letter F here. This is looking a bit trickier and I have some room. All right, letter F. Let's do some green. I have this root 11 in the denominator. I want to get rid of it. I can't have any radicals in the denominator. That's what rationalizing means. So I'm going to multiply it by root 11. If I do that, I have to multiply the top by root 11 as well. And that will not change anything because essentially I'm just multiplying by 1. Okie dokie. I'm going to have the 6 just hanging out up front, 2 times 11 under my radical sign. On the bottom I have this 4. And then I have this root 11 times root 11, or just 11 times 11. All right. I have 6 root 22 on the top, and then I have 4 times 11 on the bottom. Now I'm thinking 22. I'm trying to think of perfect squares that go into 22. 4 is not going to go into there because 4 goes into 20. 9 won't go in there. 16, 25. I don't think there's any perfect squares that go into 22, so I can't simplify that. Before I multiply the 4 and 11 on the bottom here, what I'm going to do is I'm going to just pull a 2 out of each of these. So I'm going to divide this by 2. I'm going to divide this by 2. Just to simplify my fraction out front. 6 divided by 2 gives me 3. And on the bottom, 4 divided by 2 gives me 2. I still have this times 11. And then I'll just probably do the multiplication on the bottom. So 3 root 22 over 22. There's nothing common between 3 and 22. So I'm good. I think that's where I'll leave it. Okay. I feel like I've warmed up. I'm ready to jump into letter H here. Leads, you're going to have to help me out. Make sure I don't go wrong, because this is a tricky one. I'll give you that. All right, so I have root 11 on the bottom. There's nothing I can do to simplify this thing any further. I can't subtract my radicals on the top because the number under the radical sign is different. So if I had both root 6's up there, I could combine them, but I can't. So unfortunately, I'm going to have to deal with two things in my numerator. There's nothing I can do to simplify my root 11, so I'm just going to have to go for it. I'm going to multiply the top and the bottom by root 11 over root 11. And this will allow me to get rid of that root 11 on the bottom. Okay. So on the top, I'm going to have to multiply both terms. This is the distribution principle of multiplication. Both terms inside the bracket by that root 11. Feeding the chickens. So I'm going to have 6 and then this 2 times 11 minus 2 and the 6 times 11. On the bottom, I'm going to have 4 times root 11 times root 11, or both 11s under there. Okay. I'm just going to write down everything, and then I'll simplify at the end. So 6 times 22, square root of 22, minus 2 times square root of 66 over 4 times 11. You know what? I'm just going to do 2 steps in one here. I'm going to just write this as 44. All right, now I'm thinking this 66 likely doesn't have any perfect squares that go into it, but I should check. Let's go like 66 divided by 16. Nope. Let's go 66 divided by 4. Nope. 66 divided by 9, no. 66 divided by 36, no, that's not going to work. So I'm thinking that 66 is as simple as it gets. There's no perfect squares that goes into 66. There are no perfect squares that go into 22. So those are both simplified. The only step I have at the end here is that I have a 6, a 2, and a 44 in the denominator, which are all divisible by 2. So if everything's divisible by 2, I need to pull out a 2. So 6 divided by 2, 2 divided by 2, and 44 divided by 2. So 6 divided by 2 is going to give me 3 root 22. 2 divided by 2 is going to give me 1, or just root 66 times 1, but I don't write in the 1. And then I get 22 in the denominator. Whew. So you can see something like that one question, letter H, 3H, page 10, essentially is going to take all of the ideas that we discussed when we were dealing with radicals, and it brings them all together in one question. So all of the things from adding and subtracting radicals, do you know how to do that? Do you know how to multiply radicals? And then simplifying them, all in one question. So that's why this stuff is a bit tricky. Did anybody else have any questions from this learning guide? It's kind of your last opportunity to ask before I kind of expect you guys to be submitting this learning guide and writing this test. There was some word problems down at the bottom, perimeter and area, and then there was a right triangle finding the height, and then a box. We're okay with those ones? Last chance for answers. Unit 1. Before we move on to Unit 3. Number 8. Do you want to throw in a page number, Jenna? And I will see what I can do, unless it's just the last one. No, there's no last one. 8, 8, 8. I assume it's maybe this one on page 7. The kind of variable ones under the radical sign. I think that's the only number 8 in this. Oh, there's another 8. Evaluate. Okay. So I mentioned that this would make more sense once we finished Unit 3, and obviously we haven't made it to Unit 3 yet. We're going to start it in a few minutes, but the idea is this. If you can get a variable, if you can get it so that you just have 2's. So if I took the square root of x squared, I'm just going to get x. So if I had the square root of x squared times x squared, that's going to be just x times x. The idea is if we can get our exponents into 2's, we can just get rid of them from under the radical sign. So I did A for us, a long-winded way. Maybe let's look at B here. I'll just write the answer next to this. So 2a cubed b 13b. All right. The idea is if we can break it into 2's, we can take the square root of it. So just in case you see it on a test, you should have been exposed to it. But we're going to talk about this stuff in Unit 3, and it'll make a lot more sense after we've done that. Let's look at this 18 first. Are there perfect squares that go into 18? Yeah, I can break that into 9 and 2. So I want to definitely do that. So maybe I'll just write another radical here. I have 9 times 2. So that is this 18. Now this a cubed, I'm going to write as a squared times a. We haven't really talked about exponent laws, but when we multiply our exponents, we just add them together. So I can do that. And then my b's, how many groups of 2 do I have? Well, I have 2, and then another 2, and then another 1. So we're going to actually talk about this in just a couple of minutes. When I'm multiplying my exponents, I just add them. That was something you learned in grade 9. So 2 plus 2 plus 1 gives us 5. And that's what we started with, was 5. And then with the a's, I have a 2 and a 1 gives me a 3. So as long as I can break these things into 2's, I'm okay. All right, let's continue on. The first thing I have is this square root of 9. I know that's 3. So I'm going to write down the 3. And then the square root of a squared is going to be a. The square root of b squared is going to be b. The square root of b squared is going to be b. And then everything that I didn't pull out of my radical sign just stays behind. So I have a 2 here. I have an a and a b. So I'm going to just write those in. 2ab. Because they're left. I couldn't take the square root of them, so they're still under my radical sign. I guess there's just one more thing I can do here to simplify this a bit further. I have this b and a b gives me b squared. And then I'll just rewrite this 2ab under my radical sign. So all I've done is just combine those together. So if that is really, really, really confusing, I completely understand. It'll make more sense at the end of today's class once we start talking about exponents. Unfortunately, they put this question in here when it really should have been a question that you would see in Unit 3, but it is there. There's those 3 there. If you're not getting them, don't sweat it. I promise you it'll make more sense after today's class and after Unit 3. So there you have it. Is there any further questions on this stuff, or are we all right to move on? About 45 minutes or so. I'd love to get into Unit 3. Got to keep rolling here. we're doing okay for time. I think we'll work out kind of perfect right till the end of the year. But we do have to keep moving. And Unit 3 is a bit of a really short one, but I want to go slowly through it because generally speaking, it is not the hardest, but it's kind of, there's the most spots to make mistakes. And there's a lot of rules to remember. Just want to make sure everybody's good there. So what we're going to do is we're going to poke back into the course here. I had written in Unit 1 that you were to have finished the learning guide by the 20th. Obviously that didn't work out because we took some extra time there. So that learning guide should be done today essentially. And then your exam, I would love it if your exam was done by next class. So if you can get the learning guide and the exam done by next class, that would be really good. I'd be happy with that. I just don't want you to be working on this Unit 1 stuff while we've moved on to Unit 3. So then there's this overlap sort of thing happening. And a few of you have submitted Unit 1 already, which is great. So there you go. So we're going to slide down here to Unit 3. It's on exponents. And we actually start with some stuff that you covered in grade 9, so that's good. Both these things you're going to have to print. Your learning guide is what you're going to submit. Your lessons are the ones you're going to go through with me, and you should print those off. There is a little, I don't want to call it a game, but it's kind of like an activity, I guess, here with a little video on exponent laws. So you can go through all the different exponent laws and press play. And this is Mr. Swatsky. He'll tell you all about the exponent laws. And it's just a way to remember them. Multiplying, dividing, a quiz, evaluating and simplifying, another quiz, rational exponents, applications, and we're done. It's only 4 lessons. I'll probably space it out. I doubt we'll finish this before the midterm next week. We have another 3 classes. 2 classes, yeah. So we'll get about midway through this unit before that midterm exam. So let's have a look at Unit 3. So multiplying, dividing terms with exponents. This is the lesson 1, Unit 3. I just showed you where to find that. So recall from grade 9 when we multiply terms with the same base, we add the exponents. When we divide terms with the same base, we subtract. So this was something you probably would have covered last year. This and this are both kind of like general terms. Adding and subtracting are sort of exponents. This works for everything. So let's look at some examples. If I have 7 squared, I'm going to write this out a long way. 7 squared is 7 times 7, and then I'm going to multiply by that by 7 to the power of 3, so 7 times 7 times 7. How many 7s do I have altogether? Well, I have 1, 2, 3, 4, 5. I have 5 7s. So I could write this like this. I could just write them all out, or I could just say, okay, I had 2 7s and another 3. I have 7 altogether. Let's do the same thing with this, except I'm going to write it as 2 times 2 times 2 times 2 times 2. That's 5 2s. And I'm going to divide by 3 2s. Now, I can go, okay, 2 divided by 2 gives me 1, 2 divided by 2 gives me 1, 2 divided by 2 gives me 1, and I'm left with 2 2s on the top. Or, I can just say, okay, 2 to the power of 5 divided by 2 to the power of 3 is 2 to the 5 minus 3, which equals 2 to the power of 2, which is just the exact same thing. So kind of 2 ways to do it. Now, we're going to do it always kind of this way in grade 10, just because the questions get really complex with lots of different exponents happening all at the same time. And to write it all out, it would just be too much work. And we're going to get exponents that are really big, like 20s and 30s. And you're not going to just sit there and write the variable out 20 times. So just get in the habit of just adding the exponents or subtracting them. Anything with an exponent of 0 is 1. Usually somebody asks why, and then I have to kind of think back to like my math classes in university, and I don't remember why off the top of my head, so please don't ask. I could look it up for next day. So anything to the power of 0 is 1. It's easier to explain later on once we kind of know about subtracting exponents. But for now, just take my word for it. So anytime you see something in the power of 0, it's just 1. That's just nice. Nice, easy. Everything just kind of goes to 1. Okay. So 3 to the power of 4 is exactly what you think. 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3, 27 times 3, 27 times 3, 60. Is it 81? Is that right? I'm going to go with 81. I can check it on my calculator. 3 times 3 times 3 times 3 times 3, 81. There we go. Now we're not going to just multiply it out like that every time. That would just be too much work. What we are going to do is use a button on our calculator, and I warned you guys that half of this course was learning how to use your calculator. So everyone's going to have a different button. My button on this calculator right here is this little hat. It's called a caret. It looks like a little, I don't even know what to call it. I always call it a hat because it kind of looks like a hat. But it's this kind of upside down V, I guess. That's how I can do my exponent buttons. Some of you will have a button that looks like X with a little Y next to it, like this, X with a Y. That'll be your button, or it could be a Y to the X. Some of you will have the little hat. TI-83, does anybody have a TI-83? It's the graphing calculator, or any TI graphing calculators, the 84s or the 86s or the 89s, because they're different again. With the TI series of graphing calculators, you have the hat. You don't have these buttons. These buttons are usually on like Sharp calculators. If you have a Casio or a Texas Instrument, you might have one of these guys. You have a TI-30. So that's not a graphing one, but you probably have the hat. I think the TIs, Texas Instruments, use the hat. So what I want you to do is this. I want you to go 3 hat 4 equals. Or if you have the X to the Y button, you can go 3 X to the Y 4 equals, and you should end up with 81. So I just want everyone to kind of try this basic calculation, just to make sure you kind of know which button we're talking about on your calculator, in case you need to use it. Give you a second. If anybody runs into problems, you can just put your calculator model into the chat, and I can just do a quick search and we'll find the button that you need to use. But for 99.9% of us, it's going to be the little hat, or it's going to be the X to the power of Y or Y to the power of X button. So give you a second for that. If you are doing okay, that's good. If you need a little assistance, we can search it up and find it. Some calculators don't have the cube root button, Jenna. It just kind of depends on what your calculator is kind of designed for. So sometimes you have to use the, like I have a little, on my calculator it's an X in front of it. So it's kind of, sorry, I just wrote that behind myself. It's all of the roots all at once. With the calculator I have here, my FX90, you can see it right here. It's a little X with the square root next to it. So there you go. Not everybody has the cube root. Yeah, so if you have the X, you just got to put the 3, and then you hit the button. Like the cube root is 3, and then 27 should give me 3, and it does. So whatever number you put in front of that is going to be what the little X is supposed to be. All right, I'm going to assume we're okay with that for now. If you run into problems later down the road, you can just say, running into problems. I don't really want to do these right now because I always forget the rules, but I'm going to, and then I might have to come back to this. I apologize right now because I got it wrong last year, and I think I've got it right in my head, but I want to go double check for you guys for next day. So, because the course does it a little bit differently than I was taught it, with negative numbers in front of exponents. So this is what we're going to do. When I have negative 2 to the power of 4, we want to kind of treat it this way. Kind of like this. I have a negative 1 times 2 to the power of 4. So negative 1, 2 to the power of 4 is 2 times 2 is 4, times 2 is 8, times 2 is 16. And then I'm going to end up with negative 16, which doesn't really make sense because if you were to write it out as negative 2 times negative 2 times negative 2 times negative 2, you have an even number, so you should have a positive 16. But I believe the course does it differently, and you're saying, well, Mr. Borden, you can't do math differently. Yeah, it's kind of like a semantics kind of thing. And the same way we just dealt with that, we want to think of this negative 1 times 4 to the power of 0, which is negative 1 times positive 1, because anything to the power of 1 is 1, which is going to give me negative 1. So 4 to the power of 0 is negative 1. Whereas if I have everything in the brackets, this is why it matters, I'm going to get everything in there is just positive 1. So these two are different depending on where the brackets end up. If I have negative 4 to the power of 0 with no brackets, that's going to give me negative 1. If I have negative 4 to the power of 0 and everything's in brackets, I'm going to end up with positive 1, which is really, really, really confusing. But these types of questions come up from time to time. So I am going to double check this because I don't want to mess it up for you guys. But for now, we'll assume what I just said is true. If you have a negative number and then an exponent, your answer is always just going to be a negative. If you have an exponent outside of the brackets, whatever is inside of the brackets is going to be this way. So yeah, I'll come back to it, promise. Double check, triple check my work. But for now, we're going to go with that. Weird stuff. Cross that out. We don't want to deal with it that way. Okay. Now, so far, we've kind of just dealt with numbers to exponents, but now we can deal with variables. At the very top of the page, we decided that anytime we multiply numbers, if we have the same base, so now in this example, the base is the letter C, we can just add the exponents together. So I could write this as C to the 4 plus 7 plus 2. 4 and 7 gives me 11, and 2 is going to give me 13. Now, just like combining like terms, I can combine my bases that are the same. I can't combine my x's and my y's though. So I can combine my x's, I can combine my y's, but I can't combine them together. So I'm going to have x. This one's a bit tricky because there's no exponent next to it. So that means there's just a 1 here. So this is really an x to the power of 1 plus x to the power of 5 plus x to the power of 3. And then I have my y's. I have 2 here and another 2. So I'm going to have 2 plus 2. So 1 and 5 and 3 is 9. And my y's are 2 and 2 is going to give me 4. Oh no, I have y's now in my exponents. Does anything change? Do the rules change? Is anything different? No, it's all completely the same. As long as I have the same base, I can just go with it. So I have 2 to the power of y and 2 to the power of 3y. My base is the same. I'm just going to add my exponents. So I have a y and 3y. So if I have 1y and another 3, how many y's do I have? I have 4 groups of y. So 2 to the power of 4y. Now, I'm really messy at writing at the best of times, but you can see why it would be important to take your time when you write these things down, because now you have bases and exponents, and you're trying to add these things up, and it's all a lot to take in. All right, continuing on, 4 and 4, same base, so I am going to add my exponents together. I'm going to have 2x plus 5 plus 3x minus 2. When I have x's and integers in my exponent, I simply can combine like terms, just like I would if I gave you the question 2x plus 5 plus 3x minus 2, and I said simplify. You'd say, okay, I have 2 x's, I have another 3, that means I have 5. I have this 5 and 2, that gives me negative 3. You just end up with 5x plus 3. And that is the exact same, even though it's an exponent. I'm going to combine my 2x with my 3x to give me 5x's. I'm going to combine my 5, I'm going to subtract 2 to give me plus 3. Just happens that it's an exponent. I'm going to write 3 stars in here. Now, you're going to get kind of caught up in the moment. You get just, rolling with these exponent questions. Everything's going to be great, and you're just flying along, doing really good, and you'll be like, okay, 7x minus 2 plus 2x plus 1. I have exponents. I'm going to add them together. No, you can't add exponents unless you have the same base. So we're going to write a little note. Must have same base. If you don't have the same base, you cannot combine your exponents together. So when I say base, this 2 is my base, and this 3 is my base. If they're not the same, we can't combine them. Couple more questions, and then I will leave you guys for the day. All right, let's pretend for a second. Remember, I have a 1-year-old and a 4-year-old at home, so I have a lot of opportunity to play pretend. Let's pretend I had negative 2 times 10. What would I do? Well, I'd say, okay, negative 2 times 10 is negative 20. That's easy. And then if I had x cubed times x to the 4, you'd say, oh, that's easy, Mr. Borden. You'd have x to the 3 plus 4, which is x to the 7. Okay. Does anything kind of change because I've written it all together in one sort of question? No, not really. When I am multiplying, because there's nothing between my brackets here, I know I'm multiplying. When I'm multiplying, I'm going to multiply my coefficients, which are the numbers out front. So I'm going to get this negative 2 times 10. It's going to give me negative 20. And then I'm going to multiply my same bases. I have x to the 3 and x to the 4 is x to the 7. So I'm just essentially combining these together. So we've done a lot of multiplication. We haven't done a lot of subtraction yet for the division type questions. So I'm going to write this. I'm just going to rewrite it. 4x cubed divided by 2x squared. I'm going to write it on top like this. I just like looking at my fractions this way instead of writing them kind of all on one line with the division in the middle. All right, 4 divided by 2 is going to give me 2, and 2 divided by 2 is going to give me 1. So it's going to give me 2. I'm going to end up with a 1 here. And then I'm going to subtract my exponents, so 3 minus 2. So I'm going to end up with 2, and then 3 minus 2 over 1, which is going to give me 2. 3 minus 2 is going to give me 1 over 1. And I don't want to really write in my 1s, so I will just write this as 2x. I'm going to lose this 1. I'm going to lose the denominator 1 because I don't have to include those. They're assumed to be there. All right, last one, letter C. Definitely you guys will need some time to work on these types of questions. Let's look at 90 divided by 30 first. I know 90 divided by 30 is going to give me 3 because 30 goes into 90 3 times. So I'm going to write that down as a 3. Then I'm going to have this x to the power 7 on top, and then I have a 3 on the bottom, so I'm going to subtract my exponents. And then I can do the same thing with my y's. I'm going to have y to the power of 8 on top minus the 8. So I have 8 minus the 8. I had the 7 minus that 3. This one just kind of works out really nicely. 7 minus 3 is 4. And then I have this y, a minus 8 is 0. Now we know anything to the power of 0 is going to give me 1. So this is going to give me 3x to the 4, and this is just a 1, which I don't need to write in. So I start with this big, huge mess, this 90x to the 7, y to the 8, 30x to the 3, y to the 8, and I simplify it and I just get 3x to the power 4. Again, me being a kind of a goofy, dorky math teacher, I think that's really cool that this thing looks exactly the same as this mathematically. I can simplify it down that far. And that's essentially all this unit is taking numbers and exponents and simplifying them down as far as we can get. Now, normally I would just continue on to lesson 2, but because you guys, the most of us, need to finish off our learning guide for unit 1 and then get that test written, what I'm going to do is I'm just going to give you guys some time right now to do that stuff. So I'm going to, before I do that, just look at the learning guide from this unit. So exponents learning guide. This is unit 3 learning guide. It's in the course. You should print it. If you want me to print one for you, just send me a message or just show up and I'll print it, or Mrs. Wood or Ward or somebody will print one for you. So how far did we get today? Get rid of this stuff. There we go. Negative powers. We talked a little bit about that and why it's so goofy. I'm going to double check that for you guys for next day, but have a go at those ones. Powers is repeated multiplication, multiplying powers, and should be good up to here. Simplifying should be okay, and then dividing powers. Simplifying. Okay. Sorry for the mess. This kind of happens as we go through it. So we should be good up to raising powers to exponents. We haven't done that yet. So this is, today's the 25th already. So October 25th, we should be good up to here. So this is number 5 on page 4. And I know what you're thinking, Mr. Borden, you want me to finish off a learning guide, you want me to write a test, and you want me to do 4 pages of the next learning guide, all for next day. Yeah, that is definitely a lot. Hopefully your learning guide from Unit 1 is almost done, but if it's not, then there you go. You should finish it off. What I would like you to do, I would love it if you just focused on finishing up Unit 1 before next day. So I won't see you tomorrow, but I'll see you on Thursday. And I believe instead of being the first block on Thursday, we're going to be at the 10:20 time slot on Thursday, just to give the applications or apprentice workshop math a switch. So if you've done the test for Unit 1, perfect. Do these 4 pages. If you're still working through Unit 1, I will expect you are done Unit 1 before next class, which will give you kind of the weekend to get caught up on this Unit 3 material. So next day I'm going to continue on with Unit 3. We'll do Lesson 2, which is negative exponents and reciprocals. Again, it's really easy. All of the stuff in this unit is really, really basic rules. You know, when I multiply exponents, I add them together. Easy. The problem comes when we put all the questions together. I don't want to scare you, but let's go right to like questions like this. This is what you're going to end up simplifying, stuff that looks like that. So each rule by itself, really straightforward. But when you put all the rules together, it gets really complicated really fast. And the really difficult thing with it is that there's no right way to do it. You can kind of do whatever way you want. So there's lots of different ways depending on how your brain kind of works. So you can see these things kind of look absolutely crazy, and they are a bit crazy. They're not hard. You just need to take all the basic rules we learn today and next day and just put them all together. But that's kind of where we're headed, just so you kind of have an idea of that. So we're done Lesson 1, Unit 3. The learning guide, you should finish up to page 4, question 5, if you have an opportunity to do that. But priority number 1 is getting the test written for Unit 1. So that's where we're at. Next class, I'll talk about the midterm, and I'm just going to leave you guys with that for now. So does anybody have any questions before we go? Questions about the Unit 1 material, Unit 3 material, tests, learning guides, how to submit, anything at all? Don't see anybody writing. Perfect. So you guys have about, I don't know, 20 minutes or so. Oh, you guys have the rest of the day because you don't have the next math class. I only have 20 minutes. So there you go. Use this time to finish up your Unit 1 material. I will hopefully get your password out to you if you submit it in the next couple hours by the end of the day. I'll do my best to get that. But have a great afternoon, and we will see you on Thursday. Bye now.